loop. I've brought a couple of friends with me. Some of you folks have seen them before. I have Milind here with me, as well as Felipe. Let's do another round of introductions, as they're not always here. You don't see their pretty faces as much as you see my ugly mug. So Felipe, starting with you, seeing how you're on the top with me.
Yeah, sure. So
Tell
my
us
name
who
is
you are.
Felipe. Yeah, can you hear me? All right, yeah.
Yeah, we hear you good.
Okay,
We hear you
so
good.
yeah, my name is Felipe. I work as a solutions architect, as part of the ELB team in a customer success team. And what we do there, I think we spoke before, is we help support customers as well,
Yeah.
and we do other engagements as well, like via other solutions architects. And yeah, I'm happy to be here. Excited.
Yeah, glad to have you here. You do a lot of the deep diving into the packet captures and really trying to figure out like what's going on.
Yeah,
Always
a
kind
lot
of
of time.
fascinating. You're also the one I usually run to whenever I get in a little over my head when it comes down to that low level stuff. So pretty awesome to have you here. Thank you. And then Mr. Kulkarni, my good friend Milind.
Yeah, thank you, Jamie. Thanks for having me here. As always, great to see everybody here. My name is Milind Kulkarni. I'm a product manager in the Elastic Load Balancing team. And the load balancing team is essentially, or the Elastic Load Balancers portfolio is a part of the EC2 networking umbrella of products within AWS. So that's where I fit. Um, that's why I'm here.
Yeah, cool. And of course, we got some friends of the show that are always on. Hey, Ken, how you doing? And then we have Higher Rings. Hi. Welcome. So just to kind of get into it a little bit, because we have a product announcement today. Milind, you've been fast at work on getting something out the door for network load balancer and gateway load balancer. But before we kind of get into that, I just want to dig a little bit deeper into when you create a product. And we've discussed this before on the show, but can you tell us a little bit about what goes into creating a product and how you even get an idea for a product such as this? Like, what's the effort level when you come out with something new?
That's a great question, and I think we could maybe at some point we could even do a separate topic on its own. But it's a fantastic question. Everything starts with a customer at AWS. So we work backwards from a customer, and then really try to understand what problem they really are facing. And a lot of times, then the customers have a vision of what they want it solved, or sometimes they have ideas, but then we look at the customer problem and then we invent on behalf of them. Gateway load balancer is a great example of such an innovation that we did on behalf of the customers. When customers said, I really need a way where I could do my firewalls in deploy firewalls in a scalable and available manner, and we work backwards from that. So we start backward from a customer problem, and then we evaluate the acuteness of the problem vis-a-vis lots of there are other could be other problems, and then there is a prioritization process that goes on. Then we make a formal, essentially a case internally, working backwards. Documents is what we call them. It goes through rigorous set of reviews with different audiences, including customers, partners, our sales teams, our solutions architects, our engineering teams, everybody who, executives, obviously, to really evaluate. And then we prioritize it, allocate our resources, and then we execute and finally launch. So the process can take longer or shorter depending on how big of an effort that is. But does that answer your question?
Yeah, it does. Now, here's one thing too. I'm always afraid, or was before I was, when I used to have to maintain and build networks and architectures before I joined AWS. Of any time I made any type of change to anything that was working, like, can you tell us a little bit about like what you do to prevent like a new product from breaking something else? Like, what's the testing and all that involved?
Yeah, and I'll explain, and Felipe, feel free to jump in after that as well, because you're also a
Felipe is a
big
part of
part
it.
of big part of that. We obviously take availability and security of customers is extremely seriously. So we really do not even launch anything unless we have confidence, and that's why we sometimes have private previews, otherwise known as beta programs, that we run for extended period of time. We have a lot of instrumentation to measure that. But even as we start on any product or a feature or any enhancement, we have detailed test plans that are written by engineering teams. They're reviewed again by lots of different types of audiences, product managers, solutions architects, or customer satisfaction team. Everybody reviews them. We have a lot of data as to what our customers have used in the past. We have our own domain expertise, because lots of folks come from significant industry experience, so we bring all that to the table. And then we have operational tools that are and automated tests that are built in. So the feature essentially goes from sort of unit test, and it goes to more and more level of testing at integration test with, and then load testing, scale testing, etc. So it does go through all these tests before it hits you. But Felipe, feel free to add
And
if
then
I
one of the
explain.
one of the nice parts is when we test that as well, like, so we can try to
Yeah.
break it, right?
Yeah. You say
No,
that with too
joking,
much of a smile, Felipe. We get to break it.
I like to no, honestly, we try to do a functional test, to make sure that everything works according to the plan, according to what we want to deliver to the customer, right? And at scale, right? Because I think one thing is like trying to deliver something, but delivering at the scale that we have to deliver, we must follow all guidelines and tests, like, to ensure that we are successful. But yeah, I agree with everything Milind said. But it's funny, right? We get a chance to test and try to break it. It's very interesting.
Cool. And then also, as part of this process, right, you folks also include the customer in this, so we can get actual real world feedback. So if you have a feature that's coming out, and one of our audience listeners here, obviously our customers here, want to be a part of these types of tests, what would they do to be a part of that testing?
Yeah, I think there are a couple of ways, but Philip, if you want to answer, go ahead.
So usually, we're going to have a request. So usually they are engaged with our sales team or someone from enterprise support, like that, interested on that feature that came from them. And then they are going to be the first ones that we reach out to discuss
In a
and offer.
PFR, right?
Yeah, we call it PFR, product feature request, right? And then we reach out to the customer, try to understand, how they are going to use that, and then of course there is a contract thing that we have to work with the customer as well. It's a separate thing, and then when we are in the position to offer the beta testing, then we do onboard them and have a call, discuss how it would work, and then they test it for us as well. Of course, testing is not intended to be used in production, right? Except if it's private preview, is a different story. But I think that summarizes how we can test. It's not open for everyone, right? Essentially, yeah.
Right. So PFR, ask your account team, hey, I've got a feature I need. They will open a PFR, be very explicit as to your use case, right? As to what you need it for, why, all that stuff, what it will unlock for you. And then from that process, once it gets to Milind's desk, right, and he's starting to look at all the things to build, we see and count the number of people who want this PFR. We select through the process that Melinda had just laid out for us, the product, and then we'll go back and reach for some of those customers in the PFR saying, okay, let's get a better understanding. And then that's a good way for you to be a part of this testing. So you can, of course, as Milind said, most of our products and features come from requests from our customers. We don't just build it because it's cool. We build it because you need it or you want it. So that puts a good context in what's going on. So one of the things that you mentioned, Milind, was gateway load balancer. So what I want to do for the context of this show is just kind of highlight the load balancers that we will be talking about. And I'll still include application load balancer because it's very relevant. But for those who may or may not know, we have 3 different main types of load balancers: the application load balancer, the network load balancer, and the gateway load balancer. We do have something also called a classic load balancer, which is deprecated. We're not getting rid of it. We're not doing anything. We're going to keep it patched, make sure it's secure, but it's not something that's being actively worked on. That was back in the days before VPC and Classic Link, if some of you remembered back when we were all riding our dinosaurs to work and that was a thing. But for today, application, network, and gateway load balancer. So just a high level go over those, and then I'm going to turn it over to the feature that we're talking about, and then Felipe will talk about connections because it is related to connections, and then Milind is going to talk more directly about the feature. So to start off with the different load balancers, we have the application load balancer. This works at layer 7, right? Application load balancers, a couple of quick caveats with this, very, very scalable, right? It could do path-based routing. You can offload authentication. Your target types are pretty variable. You can have it target lambdas. You can have it target IP addresses. You can have it target instances. It's dual stack, which is also amazing. You have a lot of rules that you can put into it, multiple target groups. And this is for your web-based, layer 7-based application routing, right? You'll see it a lot of times in front of EKS controllers as an ingress controller. You'll see it in front of a lot of websites. A lot of APIs will generally have an application load balancer. And the things that you need to keep in mind is when you're putting an application load balancer in a subnet, you want to make sure that subnet has enough addressing space for that load balancer to actually expand. Because as that load balancer expands, it will consume IP addresses and add it to what we call an endpoint. So that is not a fixed IP address. It is a group of IP addresses that is referenced by an FQDN or a fully qualified domain name. So please make sure you have enough address spaces wherever you place it for it to actually expand. And the way it works kind of under the hood is that we launch as a service team a sidecar VPC dedicated just for you that's attached to that endpoint. And then those bits of compute, depending on how much traffic comes in and how much you use that application load balancer, will expand in that sidecar VPC and consume those IP addresses. So the second load balancer that we also talk about is the network load balancer, or NLB. And this is kind of made of the same stuff as the hypervisor that we use, where it's literally our wire, right? We use this generally for layer 4 communication, long-lived connections. It's the back end of a lot of our users and a lot of our customers' private link, because you can attach a private link to it. It has a fixed front-end IP address, so you don't have to worry about consuming a bunch of IP addresses with it. And its main claim to fame is its ability to handle speed and spiky workloads. And then from that, we have the gateway load balancer. The gateway load balancer automatically comes with a bit of private link built in with gateway load balancer endpoints. And we call that a layer 3 gateway, layer 4 proxy. And this uses the Geneve protocol. So Geneve, which basically, for those who don't know, does total encapsulation of packets. And the whole purpose of this is to be able to put packet inspectors behind that load balancer. It can also do cross IP because of the fact that it's using endpoints. So overlapping CIDRs are okay as long as your gateway load balancer is in one VPC, and in the same region, your private link or your gateway load balancer endpoint is in another VPC. And you'd simply direct traffic to it, either inline. Some folks like to put it right between their IGWs going in and out. Other folks like to use things like what we call routing enhancements, which you can put routing tables on things like IGWs, VGWs, to basically say, if you're going to this particular destination, go to the endpoint, it goes through the gateway load balancer and then to the firewalls or packet inspectors and behind. And if that is okay, it'll send it back. The encapsulation from Geneve gets removed, and the source and destination don't know any different. So those are the high level of the three. How did I do, guys? Is there anything I missed? Any other caveats we want to talk about with those before we get into connections?
No, that's a great summary, Jamie. Yeah, that's perfect.
It's almost as if I've been talking about these for a while. I don't know.
Yeah.
And of course, if there's any questions out there from our audience, please just ask in the chat. But I almost cut you off there, Felipe. What were you going to say?
No, and yeah, no, 100%. And I think the one thing that I would just wanted to add is like the gateway load balancer, as you said already, but just to reinforce, is the packets that are ingressing on it, they are routed the same way to the appliance, so you can do whatever you want. There are customers doing 2R mode, 1R mode, which is send the packet back to the gateway load balancer, and then you allow the packets to traverse the way that they are intended to. Or you can do some other stuff like such as do network address translation at the appliance side as well, and connect somewhere else. Literally, you can do a bunch of nice things with the gateway load balancer because of these. The way that the Geneve is just transporting the packets the way that they are ingressed, right? So it's very interesting. While the NLB, it's different, right? Because the NLB, we do have to do some sort of source address or destination address translation, right? Basically, right? So that, these are the things that I think it adds to what you just said. But summary was great. Thank you.
Yeah, no worries. Perfect. So one of the things with the gateway load balancer and the networking load balancer, which is where our announcement is around today, is the idle timeout. Before today, idle timeout was fixed at 350 seconds,
Yes.
but now it will be configurable. So I'm going to turn it over to you, Felipe, to talk a little bit about why you'd want that configuration, what it means to have a timeout, and what timeouts actually kind of are for your workloads. Things to keep in mind as now you have yet another dial or another knob, if you will, to tweak on these, and some of the ramifications of that.
Before I answer why, I would like to jump in. What is idle timeout, right? First of all, right? I think that's the good recap. You mentioned the application load balancer earlier, right? The application load balancer idle timeout is how long does the load balancer wait to get some response from the target, or for how long does it wait to get something on the pipe, essentially, right? So basically, you establish a connection with the application load balancer. The load balancer receives a request. You route the request to the target, right? And then the target has a set that's configurable timeout to wait for it to generate a 504 error, for example, right? That way, basically, if you want to extend that idle timeout, you can just configure, like, oh, I know that my application has some request which takes 100 seconds instead of 60, right? Which is the default of the application load balancer. I can just go and extend that. The main difference there is like the application load balancer needs actually data, right, or the response or stream something in order to reset its idle timeout, right? While the NLB, and I think we can discuss that, the NLB, when we design that, we rely on a fixed idle timeout, because what essentially that means is that this is for how long we're going to be tracking that connection, right? That is idle, essentially, right? So when you create a connection with the network load balancer, right? So basically the SYN packet traverses the same packet that the client generates traverses the network load balancer. We perform a sort of a network address translation, and we send it back to the target, right? So if you perform a packet capture on the client and on the target, you're going to see that it's exactly the same packet, right? It's just the difference is the source IPs, right? Because if you keep the source IP preservation, you keep the client IP, but we need to change the destination, right? To put the target IP, right? That's essentially what the NLB does. And when the packet goes back to the client, the same thing applies, right? So with that in mind, 350 seconds, we keep that flow for up to 350 seconds if idle. What does it mean, right? So basically, you open a connection, you are doing a transaction there, and then these two endpoints, right? Both the client, both the target, they stop sending data, right? And then somehow, so we are tracking that connection. So we consider that an active flow, right? That's why you can monitor that an active flow count, how many flows are in active state, right? An established state. And basically, if this connection was idle for more than 350 seconds, basically the NLB forgets about that connection, right? And then essentially, if the client did not send data or the target did not send data, the NLB is no longer tracking that connection. And now, if the client sends data, it would get a TCP reset from the network load balancer, or vice versa, the target as well, right? And there was a way to prevent this from occurring, getting those resets, if you need extended. So basically, you're not sending application data, right? You're basically sitting idle there, but you wanted to keep that pipe open. Very common for for example, databases that require to you keep a pool of connections, right, that are long running, but you're not constantly making queries to the database or something like that, right? So your application has a pool of connections, right, to the database that is facing a network load balancer, and they are not actively sending data there. So basically, the way that you can implement a way extend this timeout is essentially sending TCP keep alive, right? So that way, by sending a TCP keep alive, you reset the idle timeout counter of the load balancer, and the connection can last indefinitely. Let's put it this way, right?
More or less, yeah, right.
We are going to be tracking that for as long as we are seeing the flow, right? Essentially. And that's very similar to the gate load balancer. I think one of the main differences between in this fashion between the network load balancer and Milind, correct me if you believe is different from what you think, but the main difference is the NLB there when it doesn't know what to do with the flow, right? Basically, if the flow that if it receives a packet that is not to initiate a connection, it doesn't know what to do with that, it will reset. Where the gate load balancer would interpret that as a new flow and would route to any of the any of the healthy appliances that are part of the target group of the gate load balancer.
And that also requires that those appliances have a state awareness between each other.
Exactly.
Otherwise, you might wind up with a bunch of dropped connections.
And one of the things that if you wanted to keep that flow active on the gated load balancer, there's no way for you actually to implement a keep alive on the appliance side necessarily. You would have to implement on both ends, either on the server or on the target. So if you are inspecting that flow, you may not necessarily have control of the client or the target. But it's a different discussion that we can have. And here we go. We have now configurable idle timeout, which matches majority of use cases, right? Like, and I'll allow Milind to add if I missed something.
No, I think you did great. I think the only point I wanted to just do a background for those who may not know the differences between NLB and a gateway load balancer, right? I think that's NLB is our layer 3, layer 4 load balancer, as Jamie mentioned, and it essentially is a proxy. And so it does load balancing, and it gets involved with connection handling, TCP, UDP, etc., much more than a gateway load balancer does. Gateway load balancer is exactly what it says. It's a gateway and a load balancer, but it's a gateway first. So it behaves almost like a layer 3 router on its ingress side, and therefore it is a transparent bump in the wire device. So it just takes the packet, encapsulates it, as Jamie mentioned, in an encapsulation called Geneve protocol. Geneve is nothing but a UDP encapsulation. So it takes the original packet, puts in a Geneve encapsulation, and sends it to the appliance. The appliance, when we say appliance or targets, we use the word targets and appliance interchangeably for gateway load balancer. The appliances or the targets for a gateway load balancer tend to be security devices such as firewalls, deep packet inspection engine, IDS IPS devices. A lot of time they can also be traffic mirroring or analytics type of devices. So they just expect the original packet as is. So that's the difference between NLB and a gateway load balancer. And because these two load balancers are slightly different, that's why the feature configurable idle timeout behaves slightly differently for these two features, these two platforms, because the inherent differences between those two products. So I just wanted to point it out. And Felipe pointed out, highlighted, I think, that key point, which is when after 350 seconds, when NLB forgets the connection, it will actually send a TCP reset back to the client. Gateway load balancer does not do that, because gateway load balancer does not get involved in active connection management because it's a transparent device, whereas a network load balancer does get involved in active connection management, and therefore it sends a TCP reset back to the client, whereas gateway load balancer simply forgets the connection, and any new uh, traffic packets coming after that idle time out of 350 seconds, it treats it as, oh, this is a new flow, I'm going to send it on a new target. So I think just wanted to
So you give
iterate
the
the
chance,
same point. Yeah.
you basically give the chance of the appliance to recover the flow, right? So
Yeah.
that way the appliance says, oh, now if the appliance decides to accept using like some sort of a loosened TCP control, they could
Yeah.
allow that to the flow to regain access, right? Or deny,
Yeah.
right? So we prefer to offload that to, not we prefer, right? The right thing to do is to give that opportunity to the appliance to either decide to reject or accept.
Right.
Yeah. Makes sense.
Very cool.
All
right.
Yeah. So I wanted to just show something here, how, what I just said, right? Like on how it works as with a diagram. I think that will help a little bit.
Yeah. Why don't you pop that up and I'll put it in the show?
Yeah, sure. Just 1 second. There we go. So what I just said is kind of represented in this figure here. So we have the client, we have the server, we have a network load balancer in between here, and this is the time, right? Before, right? Actually, it's the same. The only difference here is that now you can change these 350 seconds to a different value that we're going to discuss in a few minutes, right? The values, but essentially, the client is connecting, right, and basically creates a connection. Now both ends have the established state, right? A network becomes idle for a bunch of time here. The connection times out, and then if now the server decides to send a response or the client decides to send something, it would receive a TCP reset essentially, right? Because the NLB is no longer tracking that flow after this amount of time here. Essentially, that's what we just discussed. It's just a representation of how it works, right? And I'll share something else here that I mentioned about TCP keep alives. Just 1 second.
Well, whilst you're pulling that up, so Milind, what are the minimum and maximum values of this of this now?
Yeah, so good question. So today, I think maybe just doing a backswing while Felipe is pulling that. Configurable idle timeout is a feature that we launched today on NLB as well as Gateway Load Balancer. So both the platforms now have the ability for you to configure TCP idle timeout. And earlier that today the value is 350 seconds by default, and it stays as is. So your existing load balancers do not have any change. This feature works on your existing or newly created NLB or gateway load balancer. And the value that you can configure, you can go down to as low as 60 seconds and all the way up to 6,000 seconds, which is you can go down up to 1 minute or up to 100 minutes. So that's what the feature we are launching on both these platforms.
Awesome. Yeah, that's a long time. Okay, Felipe, you're back on.
It's just just to explain, like earlier we talked about the idle timeout, but one of the techniques that you could achieve, resetting the timer of the load balancer is enabling TCP keep alive, and essentially during the interval, right? In this diagram, actually, it's not correct, but I'll try to explain anyways, because here is using 2 hours as the initial time, right? Which is not technically what we want to do. But anyways, imagine that this is 300 seconds instead of 1 hour and 2 hours here, right? So like imagine that this is 300. So if you configure this initial TCP keep alive timer to be 300 seconds, right? And then after that, you send keep alive probes in the configure interval, you can leave the connection open indefinitely with the NLB, even though your TCP keep alive, even though your idle timeout is set to 350 seconds. But sometimes you don't have the way to go and configure that. So that's why we released this feature, right? So you can go and extend your idle timeout to whatever your application requires. I'm going to talk about some caveats as well later today, and then we're going to show as well how to configure that. But yeah, I just wanted to, illustrate the TCP keep alive idle timeout, and I'll ping you, Jamie, so you can share with the group here, the blogs that we wrote about that as well. I think that's quite interesting to read.
Sure. We do have a question from Ken Attard. He says, is there a way to configure this feature for an AWS network firewall gateway load balancer? Now, Ken, I'm going to just ask for a little bit of clarification. Are you referring to the fact that ANF, AWS Network Firewall, uses gateway load balancer under the hood? And you're hoping that this feature is extended to the network firewall feature? If you guys know the answer to that, let us know as well. Yeah, that's what he's asking for.
Yeah. I do know the answer to that. Our team is working, and it's a different team. Again, we are peer teams, and that team uses this launch that we launched today. And you would expect to see this on the AWS Network Firewall fairly soon. I don't want to give exact timing because that is a timing that is decided by a different team. But I wouldn't expect this to take too long. You guys should have this on the AWS Network Firewall in next probably month or two.
So you've heard it from Milind. If it doesn't show up in the next month or two, say Milind said.
Yeah, normally and I'm on there, stays on internet forever.
Yeah, exactly. Well,
Yeah.
just a caveat, we normally don't talk about any future roadmap items, but as this is a feature, and everyone on the channel, because we've talked about it quite a bit, knows that network firewall uses gateway load balancer under the hood, there would be an expectation. So yes, please expect that that is going to be the case. It always comes down again to testing, that rigorous testing that we talked about before, as to whether it'll show up sooner or later, but it is definitely on the radar for that to be done. Also, Ken had asked a different question, which is a little bit off topic, but it's still on load balancers, so I'm going to bring this one up. And actually, knowing this, I'm going to shoot this one over to Felipe. Is there a way to change the TTL for the ALB, NLB, or gateway load balancer DNS record entry? By default, it is set to 0. Says he's no, it's a bit off topic, but
I think it's 60 actually, right? Just to be on the same page, it's not 0, right? So the TTL of the application load balancer, network load balancer is set to 60 seconds. That means that whatever let's say the client or the resolver of the client is when it resolves the DNS name of the application load balancer, it will cache for that amount of time, 60 seconds. And only after that, you would do another query. So there is no way for you to configure that today, right? To change that. 60 seconds is the default. But yeah, we can discuss about having that as a PFR, like if we understand better the use case, what you're trying to achieve. Again, the reason why 60 seconds is we want to react fast on changes for the application load balancer, right? And so basically, as Jamie said in the beginning, each time. So when you create an application load balancer, we create a set of nodes, we call nodes internally, and actually externally as well. And the way that it works is like we spin up a node per availability zone. So you configure the load balancer with 3 AZs, we're going to have 1 node per AZ at least. That's the minimum, right? And then as we scale, right, we change the size of the node to bigger nodes, and then we replace the nodes, replace the IPs on the DNS record. And or if something fails, we want to replace that as well. We need to update the DNS record. So that's why the TTL is 60 seconds short, right? That's why it's short. And we don't. So I don't see reasons to extend the NLB, the ALB TTL. And NLB is, although the NLB IPs doesn't change, one thing that we care about is availability, right? So you probably have noticed. So there's we can talk about that feature in a different show, but just to recap, you can essentially the NLB also has 1 IP per availability zone, but these IPs are static, right? We don't change these IPs, right? So basically, upon the creation of the network load balancer, they always remain the same. Nevertheless, the reason why we tell customers, although the IPs are static, in order to ensure availability, in case something goes wrong with the availability zone, or either by the targets, right? The targets are offline, or you have a disruption on your targets there. You're going to notice that if all targets fail in one AZ, the IP is removed from the DNS record. Even though the IPs are static, it won't change. It won't return the IP of the AZ that has no healthy targets, essentially, right? And this is configurable. We can look for minimal healthy targets, right? Like in the feature, right? And that's why the TTL is 60 seconds, because we want to ensure that the clients always retrieve IPs that are healthy and fresh to connect, right? Essentially.
And
I hope that answers.
And realistically too, 60 seconds is a good healthy number balance, because we do want that really quick response. But if you do it too quickly, if you're talking like 30 seconds or 10 seconds, now you're starting to do a pattern where you're flooding your network with requests. You could start
DNS requests, essentially.
Yeah, exactly. And then also the processing time for that, because imagine this at scale with Route 53. I think we're now one of the most used DNS services on the internet, right? So you got to keep in mind, like, where's that healthy balance between how can we answer really quickly, fast fail, recover really, really fast, but not overtax the system at the detriment of our customers. So
100%.
Yeah, just kind of throwing that out there as well. So circling back a bit, and again, please, anybody have any questions related to ELBs or even networking in general, please keep them coming. But what we want to do now is probably want to talk about enabling. Oh, here we have another one from Tech Field. Tech, nice to see you again. Sorry for the basic question, but do the nodes of ELB expand based on traffic only in the case of ALB and not
Okay.
for NLB? Yeah.
I'll,
You want
I'll
to
take
you do this all
I'll
the
take
time.
that
I
one.
usually answer this, so you go ahead and grab it.
One difference is the ALB, the way that is designed, right? So ALB, when ALB needs to, get more traffic, we do change the node. We provision a new node. We change that record on the DNS, and that way the clients are going now to the new nodes, right? That's why the record is 60 seconds. For NLB, that happens under the hood, right? It's a software-defined network, right? So basically, the way that we do that is all virtualized, right? So we basically can add, remove boxes, without changing the IP. But essentially, it will scale same way as ALB. Not exactly the same way, but similarly, we are going to add capacity transparently. And on the ALB is different, because on the ALB we need to, first we need to do processing the HTTP request, so on the NLB we do TCP, right? So the way that the scaling works is slightly different, but both does the same. They add and remove capacity based on dynamically.
But they're independent of one another. So if you have one or the other, right?
Yeah.
So like, let's just say you're using that feature of, the target ALB as a target of NLB, right? The traffic going through, if that's linear, both of them are going to scale.
Both of them are going to scale, yeah.
But as Felipe said, they scale differently. I always like to make the analogy of, for the NLB, you get a slice of the pie, and we just increase that slice a little bit more for you, right? Because of the fact that that pie is ever long going, or maybe a river will just divert more of that river, more of that time and resources for your load balancer to make that. But on the ALB, first thing we do is we scale horizontally, right? And then we start scaling vertically. I did that reverse. First we scale vertically, and then we scale horizontally. So yeah, because when we scale vertically, right, we want to make sure that there's enough processing power for all that layer 7 goodness that you're trying to do, and then horizontally to make sure there's enough spread so that it handles all the traffic that you need. But that's how both of them kind of get going in the process. Yeah. We do have a couple of other questions. Please keep them coming. But what I want to do is just make sure that we at least hit how to enable configure idle timeout. And what we do on the console to get that going. But one of the questions that I had whilst Felipe is getting that ready, because he wants to show us what's going on with the console. Milind, for Gateway Load Balancer and for Network Load Balancer, for this feature, do we have to reload or launch, or are they there right out of the gate?
Great question. This feature you can enable on your existing Gateway Load Balancer or Network Load Balancer. You don't have to restart them. You don't have to do anything. You just go to Felipe will show how to do that on using console or through API, but you don't need to do recreate, for example, your load balancers, or you don't need to restart them at all. You can enable this feature on your load balancers that could be in production, could be in testing, anywhere.
That's a good thing, because I do remember for some features, right, it does require you to relaunch just because of the intricacies of that feature. Correct. And trying to maintain a secured, stable connection. Sometimes it requires you to reset so that you don't have any anomalies as you will in your current architecture. I'm going to bring up Hiring's one question real quick about DNS, and then switch over to Felipe. Talking about DNS, why Amazon doesn't have a public DNS like Google's 8.8.8. Internet clients could benefit from Route 53 sturdiness. That is absolutely correct. You're absolutely right. But here's the thing about the way, the methodologies of how we do things here at AWS versus things that are done with Google, is that with AWS, one of the things we want to make sure of is that we always reserve as much capacity as we possibly can for our customers. Right. So everything that we build, especially Route 53, even though it's a public service and it could be bounced off of, much like the 8.8.8, the two things that we're always really, really concerned with is the capacity, making sure our customers, first-class citizens, are being handled and their workloads are being handled and treated in the most calm and then secure manner. We also don't want to expose anything that we don't have to expose to the internet or subject to the internet, unless we absolutely 100% control those threat surfaces. And again, if we're going to be exposing something like that to the internet, I'm not saying we'll never do something like that in the future, but we need to make sure that we have a very good handle on all the knobs and dials to make sure that things remain secure and performant for our customers, because that has to be the way it is. We do have one other comment from Robert Tables, another good friend of the show. I love NLB taking this new feature to my team as we speak. So, Milind, you're already affecting
Awesome.
different teams.
Thank you, Robert. I really appreciate this comment. I love it. When we get direct feedback like this, it makes us feel good that that kind of direct feedback is always helpful. And I think one of the things after maybe we can also talk about is I'm also curious to know what are your use cases that you would want to use this configurable idle timeout, and we can talk. But let's go ahead first and
Yeah.
see what Felipe has, and then we can come back to the discussion, because I also want this to be a two-way street, a dialogue. We are as much interested in hearing back directly from you, learning from your deployments, learning from your questions sometimes as well. So please keep them coming.
So, Robert, if you can, why don't you tell us a little bit in the comments of what you're going to be doing with this, or what you're thinking about this, whilst I bring this up and Felipe walks us through the new feature.
Yeah, actually, it's quite simple to enable that, or to change that setting on your load balancer. One thing that you're going to notice is that this attribute, instead of being in this attribute page here, is actually on the listener side, because these you apply per listener essentially, right? So in the load balancer, you go to your TCP listener, and then you select your TCP listener, and you say, what is the idle timeout for this TCP listener, right? So then you go to the TCP listener and you change the TCP idle timeout, and you can see the range here that folks asked earlier, right? So by default, if you create a load balancer, you're going to see that it's going to be 350 seconds. And the reason why it's 350 seconds is that we want to keep backwards compatibility, right? So we don't want to introduce a new change that would change the experience that you have when you are creating new load balancers, right? So that's why the default will remain 350 seconds. But essentially, you can just go and configure that to higher or lower than that. And we are going to explore reasons to have lower and reasons for having higher, right? But yeah, simply, but before that, let me, just change mine. And then you go here, I'll set to 600 seconds, which is 10 minutes, and then save the changes, and that's it. It will propagate that.
Any interrupts or anything like that, or is traffic just flowing through normally?
Traffic will keep flowing normally, right? You shouldn't expect any problems. You can do that right now, and no problem should be experienced. It's the same, essentially, doing that API is the same as registering a new target, essentially, right? If you really think, yeah.
Right.
So which you do all the time, right? And that's for the NLB, right? For the NLB is simple as that, right? You go to, again, to recap, go to your listener, change the attribute, and that's it, right? So it's on the listener side. Oh, let me go back here. Yeah, listener, click on the listener that you want to change the traffic, and yeah, and then you added the listener. Okay, that's it.
And one more question, just to make sure I answer it, just for ask it for completeness. Different listeners can have different timeouts. It doesn't have to be the same across the board.
That's correct. That's correct. Yeah, there we go. Add it, and that's it. Okay. For the target, for the gateway load balancer, then this is slightly different. Okay. For the reason is you only have one listener, right? the gateway load balancer, right? Yeah. And basically, you go to, again, to your gateway load balancer listener, right? And then you added the listener here, and no, it's not here. Sorry. Let me reload. I think it's a little bit slow.
It's thinking a little bit.
Yeah, it's thinking a little bit. It's always like that, right?
Mm-hmm.
And listener details. Yeah, actually, you go here. Sorry, you go to the. Let me go back to the load balancer. So I show the same way. So listeners, click here, view listener details. Okay, and then the attribute is here, right? And then you click here, and you're going to see that you're seeing TCP idle timeout, because only applies to TCP flows flowing through the gateway load balancer. Okay, so then you go and configure whatever your appliance is. Best practice here would be, what is the how long your appliance is tracking those flows, right? So you configure the idle timeout of the gateway load balancer to be slightly higher than the appliance idle timeout. So basically, let's say that you're using an appliance that uses 1 hour, right? So you're going to configure your
Such as a
appliance.
Palo Alto, right?
Yeah, but yeah, exactly. So if you're deploying the default and you're not changing for how long, right? You go and set your settings to 3,000 600 seconds, for example, and that way now instead of each 350 seconds that the flow is idle getting routed to a different appliance, now you know that this flow is going to be sticky with that appliance, except if the appliance goes unhealthy, right? Which is a different story. We're not talking about that here. If everything is according to the plan, everything is healthy, we are going to keep that flow sticky with that appliance for idle, right? For if it's idle for longer than for up to 3,700 seconds now. If the flow is active and is sending data all the time, they can last indefinitely. So that's not one thing that I wanted to call out. You're not configuring the maximum amount of time that the flow exists. You're basically just configuring for how long this flow is kept. The load balancer will remember about that flow, even though the load balancer is not seeing any packet for that flow, right?
I want to repeat that because it's important. It's a very important thing. We're going to configure this for how long we want this to remain active, not for the entire length of the entire connection, because doing that could be quite catastrophic. If you're trying to say, okay, I want all my flows to be this, and I'm just going to cut them all off. That's not the way to think.
That's not the way that we handle this here. Yeah. Basically, one thing that you need to be careful here is now you're increasing that, TCP idle timeout. So then what it means is that we are going to accumulate more active flows, right, for a longer time. Except when we see, one thing that is important to know is like when we see both connection being closed, we consider the flow, closed, right? So we are going to remove that from the active flow count, right? But if we are not seeing the fence or the reset from these flows, right, then this flow remains on the table for for this amount of time, right, until this time elapses, right? And then after that, we would forget about the flow and reduce the active flow count. So pay attention to that, because one of the dimensions that you pay is flows being active as well, right? So again, it's good, but you should use wisely, right? Don't go and change this, because at the end it could cost you more money, right? So that does make sense.
Yeah, definitely.
But basically, that's it. You go and change it and save it similarly to the network load balancer. No impact at all on existing flows, right? So they will remain the same, and yeah, that's it.
Why just slightly over as opposed to matching directly what you want your flows to time out on?
I'll say again. Sorry, Jamie. I didn't.
So why would you set it just above your maximum as opposed?
Oh, that's a very good question. Yeah, that's by experience. What we learn is the following, right? So if you set it slightly below, that means that let's give an example. Let's say that your idle timeout on your appliance is set to 1 hour, and you set your load balancer idle timeout to 59 minutes. So if this flow is idle for 59 minutes, right, and then somehow either the client or the target decides to send data, the flow is no longer being tracked. It will be routed to any of the targets, right, or any of the appliances, right, as if there were a new flow. It's the same problem as having a shorter idle timeout. So you're not matching both. If you have higher, basically what you're doing is the load balancer is tracking for longer, right? And now, even though the appliance no longer recognizes that as a new flow, as an existing flow, we are still giving the opportunity to the same appliance to decide whether the packet should be allowed or not, right? So basically, you don't create a race condition where you add an element of it become random, right, just before the appliance forgets about that flow, right? So it's slightly higher. It doesn't have to be 100 seconds larger, right, but at least 5 seconds. That's what we would recommend. Yeah, does make sense?
So 5-second buffer time is the minimum you recommend.
I would say 5 seconds is good enough, right? For because now you know for sure that both state machines of the gated load balancer and the appliance will be kind of synchronized.
Right. Yeah. And I would also imagine too, like depending on the appliances that you're using, since Gateway Load Balancer really does shine with working with our partners for packet inspection devices, such as, like again mentioned, Palo Alto, Barracuda, and that they generally have information about the idle timeout and what should be configured. And I'm sure that now that we've released this feature, they may update their documentation as well, that is concerning this. So I would also make sure that you look to your partner or your appliance vendor and to see what they recommend to make sure that you're
100%.
falling within the different traffic. So Milind, Robert got back to us as to what he's going to do. I'll pop this up on the screen here. Robert says this is going to be deployed as a private NLB with traffic ingress egress via a centralized inspection VPC that performs different inspections, Palo, Zscaler, based on the type of traffic. Flexibility will help with the stickiness. You guys have any comments?
Perfect. No, perfect use case. Thank you for sharing that. That makes a lot of sense. And just Felipe just showed you how easy it is to configure through console. Felipe, just a question: if somebody wants to configure it using, let's say, API, how would they do it? What do they need to do?
Actually, we shared that in the blog post that we just released. I'll ping this blog post as well because they are great. Jamie, I would appreciate if you can just copy the links to the audience because, yeah.
Yeah, perfect. Yeah, while Felipe is doing that, we published 2 blogs. One for NLB, how to use this feature on NLB using console as well as API. And we wrote another blog for Gateway Load Balancer, again showing exactly how to do this using console and API. So I think those 2, please take a look at those 2 blogs. A lot of
I'll
it
share
is
my screen.
common. Yeah, a lot of it is common.
I am posting both of the links, and your screen is up.
So basically, again, this is a listener attribute, right? So this is for the gateway load balancer, right? So basically, is you're going to call AWS ELB-v2, right? Modify listener attribute. You're going to say first you're going to have to find the ARN of your listener, right? So you're going to describe your load balancer, retrieve the listener ARN, right? And then that's it. Your listener attribute, and the key is TCP idle timeout value second 3700 and whatever number you want, right? Actually, we are not suggesting 3,700. It's just an example, right? By any means, we are not suggesting a number. And for NLB, it's quite similar, right? So actually, the structure is basically the same, right?
Same.
AWS ELB-v2, modify listener attributes, find your listener attributes, and you're passing the key and the value that you want, right? And yeah, that's it. And then similar to what we just explained on the listener side, you're going to, basically have your idle timeout pre-configured.
CloudFormation support's already there, Milind? Isn't that a rule now that we have to have that always available?
Yes.
And the reason why I bring that up too is because some of our folks listening here don't just have 1 or 2 or 3 network load balancers or gateway load balancers. Some of our friends have thousands, right? So a good idea would be is if you're going to be doing something for general applications, I would group them together in the different groups, create a CloudFormation template, set your values, make sure that you get it checked out, maybe check it into a Git repo or something like that, and then roll it out. And the main reason for that too is, let's say if there's an issue, like there's a problem that you have where maybe you set it a little too aggressively or you set it a little too wide. As you're going through a lot of those different load balancers, you could be causing yourself a condition through your application catching up while you're still configuring. And then by the time you're done configuring, you have a bit of a mess. So with something like CloudFormation or Terraform, you can go ahead and set it in one big swoop, right? Get that going. And then yes, exactly, Robert Tables, you said small reversible changes. That's what you want to do. So you can go ahead and just hit it, see what's going on, pull it back. And you can even do it in a small microcosm of different subsets.
Yeah, I think the main thing that I would recommend to, first of all, understand the use case, what you're trying to achieve, right? If you know for sure that you're getting those, especially NLB, right? You get resets and you know that you need to extend the amount of time you want the flow to be considered idle, right? Definitely. But, you should evaluate that and make the call, right? And if you have questions about that, right? Like how to measure that, how to understand that, how long the flow is active, how long the flow is established, right? So you can use the NLB has a metric for NLB reset count, right? So for how many resets the NLB is generating, right? You can monitor that metric, right? But if you are not sure, if you need assistance on monitoring these things, you can always reach out to the AWS support team, and they are going to be happy to discuss with you and your team.
What's the reset metric, would you say, Felipe, that you should start considering resetting that timeout value?
So actually, the beauty of that is that there's no value that like we would give to
I was
customers. Like,
worried.
yeah.
Yeah.
But like one metric that I will just ping the metric name here is NLB reset count, right? Just get here, and then we can forward that to the audience as well. One second. TCP. It's called TCP ELB reset count, right? There. Yeah, this one, and is in this page here. And essentially, the NLB generates that when the load balancer does not recognize a packet, right? Like it never happens for SYN packets, because a SYN packet that comes from the client is always going to be routed to a different target, healthy target, right? But if it's a packet that, let's say that's a packet that arrives random to the load balancer after, 600 seconds, and the idle timeout is 350 seconds, this packet will be reset. And this metric will be incremented, right? So if you know that your clients are getting resets every now and then, and you know that you keep idle flow for longer than 350 seconds, right? And you have to measure both, right? By looking the metric alone doesn't say much, right? So you have to look at both, and then by checking that, and then you say, oh, now it makes sense for me to increase, because my application, for example, my database, the idle timeout of my database is configured to 1,000 seconds, and I don't want to change that because that's the way that it has always worked, right? So you can increase the idle timeout of NLB to something around 1,005, right? And then for sure that this flow is going to be kept active. And now,
and the ramifications, honestly, of changing the flow
Yeah.
timeouts on a database is much greater, because I do believe on most of them it requires downtime. Whereas on the NLB, it does, as we just shown, it doesn't.
Yeah, 100%.
So now, one question I have for you, because I also want to give you a time to show this off if you also want to pull it up. Is this going to be on the ELB best practices site?
We are trying to write. We are writing about monitoring your flows and how long you're keeping your flows. The trick is like I'm more a Linux person than a Windows person, right? So I have to partner with someone from the Windows space to help customers to monitor on the Windows side. But yeah, from the Linux side, we are writing a content to help customers to identify for how long their flows are kept active, right? Because that would benefit them then to have this sort of implementation on the best practices, right? So yeah.
Right. I just pasted a link for the ELB best practices that Felipe and team were working on. There's a lot of information, a wealth of information in there for folks that even if you think like how things are going with ELB, as you can tell, Milind is always busy trying to improve a lot of our load balancers. And there's new features and changes that are coming out that could be changing the way that load balancers operate or think for the better. And to take advantage of it, I would always be looking back here to this site. I even use it myself from time to time as well when I'm talking to customers and trying to figure out things and like, what should I recommend here? As Felipe is one of my go-to folks. Sometimes I don't have a bat phone that reaches directly to his desk. So I go to this.
You know how to find me. You know how.
I do know how to find you. But now that we've got the feature, we know a bit about different ELBs. We've kind of ramped up on that. We've got an example of use case. And if anybody else has a use case or a question about the use cases, please don't hesitate, put it in the chat and we'll bring it up. But now's the time to come down to caveats.
Yeah, like, Jamie, sorry, before we go into caveats, maybe I just want to do sort of, again, one more time, a little bit of backswing just to be sure, right? I know sometimes it's better to over communicate because we have, sometimes. So I just want to highlight, so which situations this feature will be helpful. So from time to time, as Felipe was explaining the feature, the 350 second of idle timeout works for majority of applications. There are very few applications that will stay idle for 350 seconds or longer, right? But then we do see there is other use cases that show up, maybe in financial, maybe in FTP related, maybe some database queries that go and get some data on FTP. So on those types of applications, maybe even some IoT types of application, we do see that they have longer idle flow. So that the device will send the data, traffic mirroring, for example, or streaming type of device. It will send the data and will stay idle for good 5-6 minutes. 350 seconds is about 6 minutes. So those types of applications will benefit from this. So just wanted to highlight that if you have those kind of applications, financial applications, database applications, FTP, that you are looking to onboard to cloud or maybe migrate them, this is the feature that helps you enable do that. Same thing with we see with gateway load balancer. Most commercial firewalls that Jamie was talking about, which are maybe Palo Alto, Checkpoint, Cisco, Fortinet, they tend to have a default firewall timeout of 60 minutes, is what we see. So firewalls do keep that connection open for 60 minutes. So not every security team has the ability to go and change the security settings for whatever reasons. Maybe they have some policies in place, maybe there is just a perceived risk of changing that. So this feature helps you align on the gateway load balancer the timeout that aligns with your firewall timeout. So again, just wanted to highlight where exactly, if your applications, if you're thinking of great feature, but where should I use it, this is the place where you use it. So for NLB, you want to use it on and gateway load balancer, you want to use it on sort of FTP based applications, your database applications. Maybe there are some legacy apps that you have, a long tail of legacy apps that you're waiting for. This feature will help you if you are looking to align your traffic with the firewalls a timeout, then this is the feature. So just wanted to call that out. Now, having
Yeah.
said that, sorry, go ahead, Jamie.
No, I was going to say, yeah, I do remember talking to a customer using IoT on farm equipment where they really needed to extend that out just because of the fact that it didn't want to go through authentication procedures every single time, because that was kind of built into the communication from their devices out in the fields, literally the fields, back to the operations center that they were having in AWS. So one of their concerns was is they didn't want it, they wanted it more or less sticky session to keep up and alive, and it to be responsive when they needed it. So they had to extend the idle timeout, or really wanted to extend the idle timeout to help meet these needs.
Absolutely great. So having said that, right? So now, having said that,
It is
I have
literally
the green grass. I like the comment.
That's
I
very
have the
true.
green, literally in the green grass. Yes.
Yeah.
Interesting comment. Yeah. So having said that, now let's understand the caveats for this feature, right? And as you know, in AWS, we do things iteratively. We'll do something and then we'll keep improving incrementally. As Jamie mentioned, it's not just me who's busy. Everybody is busy working. I know you guys are busy daily doing your thing as well.
Well,
So
you're
we
always
all
too busy for me. Every time I want to talk to you, like, I'm busy. I'm just kidding. I'm kidding. He's never busy.
we all are.
Yeah.
So what are the caveats, right? So for NLB and GWLB. So let me just highlight some of those. And Felipe, feel free to correct me if I'm wrong here. And same with you, Jamie, because you've tested this feature in beta as well before we launched it. So on the NLB, maybe even before we do that, we call this feature explicitly as TCP configurable idle timeout. So this works only for TCP because TCP is very connection oriented. It is very finicky about keeping connections open, etc. That's why TCP applications usually are the most sensitive to these sort of timeouts. So this feature works only for TCP. Obvious to say, but I just want to call that out. So that's one. That means it doesn't work, and it's not designed to work for UDP and ICMP. UDP is connectionless protocol, so it doesn't really matter for UDP. At least
Just
at this
ruined my
point.
joke about UDP timeouts. Like, how can I set that? You're supposed to say, I don't care.
Yes, UDP is doesn't really care. So, but if there is some good use case, let us know. I mean, we're always willing to hear, listen. Things, world is changing. We all are changing. The needs are changing. So let us know. We can consider these in the future. Another thing is TLS. If you enable TLS with NLB on this feature cannot keep track of that yet. We may do it in the future, but right now we see that use case as very, very limited, and there's always a trade-off of effort versus the benefits that we give to customers. So we sort of said we'll do it at some other point. And the third caveat on NLB is any traffic that's coming from AGA or AWS Global Accelerator cannot take benefit of this feature yet, because there is an internal under the hood mechanism that goes between AGA and NLB. So AWS has another product called AWS Global Accelerator that sits at the edge of Amazon network. It's a different team, but that AGA talks to NLB under the hood using a different type of underlying architecture, called a different ENI. We call it a V2 and ENI. So that work will need to happen with both the teams, and we'll make it happen at some point. We haven't made the decision, but I just want to call that out, that these are the three caveats that are on NLB. Again, let me summarize them. Number one, this is only TCP feature. Number two, this would not work for TLS traffic. And number three, if you have a AGA or Amazon AWS Global Accelerator, this feature doesn't work, or it's not designed to work. It doesn't work means it's not designed to work yet.
So basically, that means that you can change the configuration of your NLB, but it won't apply to the AGA side, right? Thing, yeah.
Correct. Yeah.
Yeah.
And then for gateway load balancer, there are similar caveats. Again, it's a TCP feature, so it works only on TCP. Second is gateway load balancer has a type of stickiness that you can have. The default stickiness is 5-tuple stickiness. That means the gateway load balancer will stick a flow using 5-tuple, and then by 5-tuple I mean the source IP address, the destination IP address, the protocol, the source port, and a destination port. So because TCP needs all these 5, this feature will work only when your gateway load balancer is doing 5-tuple stickiness. That means if you are doing a 2-tuple stickiness or 3-tuple stickiness, then this feature cannot work, because gateway load balancer is blind to what protocol is going through. It doesn't know that there is a TCP going on. It doesn't really care, because you are telling the gateway load balancer to look at only 3 things: source IP, destination IP, and protocol. That's it, right? So just want to call that caveat out. If you try to configure something like this, then the gateway load balancer will give you an error. So just wanted to call those 2 caveats.
Oh, that's a very important caveat actually for the gateway load balancer. Yeah, 5-tuple. Yeah.
Yeah.
And for folks, just again to reiterate, with AGA, with NLB generally, or sorry, AGA or Global Accelerator uses ALB or NLB as what they call endpoints. It could also use IP addresses as endpoints. So typically, if you're using an ELB, right, and it's not ALB, this is definitely something that will affect you. So if you have the need to do the configurable idle timeout, or if you fall within the confines of what Milind had said earlier, if you fall within one of those verticals and you're finding that you're needing to increase that, AGA will not honor that at this point in time.
Yeah, but like if you have a use case for that, bring it up to your solutions architect or or
Right.
technical account manager. We can discuss alternatives for this if you really need that.
Of course. And two, as you also mentioned, Felipe, even though the AGA or the Global Accelerator won't adhere or won't honor it, it doesn't mean that it's not actually in use for the NLB itself. So if you have some applications, because I have seen that too, think of it as kind of like a split horizon, if you will, or a split method of reaching those services, where they have their customers reach from the outside through an AGA, and internally you may have some processes reaching directly to the NLB in question. It'll still honor it for the NLB. So just keep that in mind too if you do set that.
Makes sense.
Yeah, cool. So is there any other features or questions or anything that we want to bring up to our audience, or any other questions from the audience? Silence
If not,
is gold.
Yeah, if not, I'll add, just to summarize as well, like
Sure.
when you configure that, please keep in mind that higher idle timeout means more active flows, right? And then you need to track that. And if you need to, if you're somehow you think that you want to reduce that as well, we support it below 350 seconds. You can go down to 60 seconds actually. And then what would be the use case for that is like if you don't want to pile active flows for 350, that you're using short-lived connections, they last up to 100 seconds. You can go and reduce that, and that way, even if the flow is idle, you don't care about them, right? So you can reduce the active flow count as well. Again, you should always match your application timeout with the ELB timeout, right? And and essentially you should allow both endpoints, right? Meaning the client and the target to close the connection gracefully, right? Because reducing the idle timeout or increasing, right? You're basically allowing the load balancer to track for a lot more time or less time, but you're not effectively changing the way that the client and the target, are thinking about the flow. You're just, changing what is in the middle to say let's track for more time or less time, right? Essentially, you should always allow both endpoints to close connections gracefully. And when the flows are closed with TCP things, right, and so on, these also get removed from the active flow count table, right? If that makes sense.
It does. It does. We had Sridhar who is the PM from Transit Gateway and CloudWAN on, I believe it was last week, and Ken came up with a bunch of PFR ideas for him. So Ken has a PFR idea for you, Milind, and if anybody else has a PFR idea, PFR to support range of ports for NLB use case, VoIP, PABX. I don't know what PABX is.
PABX is PABX. I think I understood what he's saying. I would love to understand the use case, Ken. My hunch is you're probably saying maybe there is the 5 tuple isn't changing, is my hunch, what you're saying. But would love to understand the PFR. I think I'm always open for interesting ideas. As I said, we always work backward from you folks. So it's always appreciated. But Jamie, I also wanted to, if I may, just wanted to cover some basic topics. Some very basic and obvious topics. So, does this feature cost to operate? No. This feature is there's no additional cost for using this feature. It's your existing charge that you pay for using NLB or gateway load balance through LCUs is how you will get measured. But as Felipe was mentioning, be judicious as to how you use this feature, because if you keep the connection timeout longer, that means you are going to accumulate more number of flows or connections, and you will be charged more on that. So there's always a trade-off. The longer you have the timeout, the more number of entries you're going to accumulate. That means you will also pay more. So try to find a balance. We recommend going gradually, increasing the timeout gradually. So that's one point I wanted to make, that it's the feature
using structured code.
Yes. Yeah, absolutely. So you can backtrack if you need to. So no additional cost to using this feature. And second is region availability. I usually get this question asked all the time. Which regions, where is it available, etc. This feature is available in all commercial regions, in and as well as government cloud region, as well as China region. So all the AWS regions that you see commercially advertised everywhere, this feature is available for both NLB and gateway load balancer. So just wanted to call that out.
That makes sense. So I have a question actually that we brought up a couple of times, and I've been asked this to explain this, and seeing how we have the PM on here and one of the guys that dives deep into packets. Can you explain a little bit about what an LCU is?
Oh, great question. Is that a question for me? Is that a trick question, Jamie?
Not a trick question. I'm just saying that, this is something I get asked a lot. I usually have to explain it, so I'd like to hear it from you guys as to an LCU.
I'll give it a try, and Felipe, feel free to join. LCU stands for Load Balancer Capacity Units. It's a measurement of how you consume your load balancer, because we essentially, AWS bills you for the usage of your load balancer. For many devices, it's easy to just capture the amount of traffic that's passing through the device, the amount of gigabytes that are passing through the device, and that's sufficient. For example, private link or transit gateway, they are passing bytes in and out. So it's fairly simple to measure and build based on that. Load balancers are different, because load balancers, there are 3 axes of load balancers that get consumed. One is the amount of traffic. So essentially, it's a gigabyte of traffic. So we therefore, LCU consists of 3 different things. Number 1 is the amount of traffic that's getting sent over the load balancer. So that's the gigabits of traffic or gigabytes of traffic. That's the first dimension. The second dimension is the number of active flows, which is how many number of flows that your load balancer has at any given instant. So that's another measurement. There are some applications that will keep a large number of flows active, whereas some application that will keep only few number of flows active. So your usage of number of active flows will change depending on the application. So that's the second metric. And the third metric is the flows per second or connections per second. Essentially, your application is trying to establish connections with your targets. So that rate of connection is a third metric. Depending again on your application, there are three different usages can have, and therefore we have this combined metric of three dimensions LCU, which has three things again, as I mentioned. One is the amount of traffic, which is gigabits. Second is the number of active flows, and third is the active flows per second. And whichever one is higher is what you will get billed on. So that's what an LCU is. But I'll pause there, see if Felipe, if that makes sense, if we need to simplify it even further. I do realize that it might be a complex concept to get, but that's at least how I try to simplify.
Awesome.
Yeah,
Yeah, that's.
I'm
Go
just sharing my screen here with the documentation and, as well. Like I think, I don't know if I need to make it a little bit bigger. And it's exactly summarizing, right? Like like we have for all load balancers here, but talking specifically about the network load balancer, it tells what an LCU. So basically, you pay for each LCU that you consume, right? And basically, each LCU comes with either it's like 800 new TCP connections per second, 100,000 active TCP connections, 1 gigabyte per hour, right? So whatever you're using from one of these three is you pay for the highest, right? And then it consumes the LCU essentially, right? So one thing that you should be aware is, like, if you increase your idle timeout, you're going to be likely, right, if you do have if your targets are not closing connections or your clients are not closing connections, you're likely going to have more active connections, right? So if you maybe the cost doesn't change if you're transferring more bytes, right? Like then if the highest dimension is the data transfer, right, or the data processed by the load balancer, then maybe you wouldn't pay for more active connections because you're already paying on the gigabyte side. But it's something to keep an eye on, right? So if you have something that is, if you're breaching the active TCP flow count, right, then definitely, right, by increasing that, you're gonna end up paying more for the LCU, right? Because each LCU supports 100,000 active TCP flows.
So
And
that's great. That's great. Philippe, just do you mind highlighting the just few lines above where it actually defines in bold what are the three dimensions, right? There's number of connections or active flows, right? Just one
yeah,
below, up, just above that. I think this it
yeah,
defines.
sure,
Yeah, these
yeah,
three. Yeah, exactly. Those
yeah.
three. It
So
defines
whichever,
what an LCU comprises.
yeah, exactly, yeah. The three dimensions. And the gate load balancer is sort of similar, right? New flows, new connections or flows, active connections or flows, and process bytes. It's pretty similar, right, Milind?
Yeah, it's very similar.
Yeah.
So I know, Jamie. I don't know how we are doing on time, but I do see the comments. I can see the comments here.
Yep.
Robert, you are asking, is there any concern with private link? No, there is no concern with private link. This works perfectly.
That's a
No
good question,
problem.
actually, right?
Yeah,
That
Private
is a
link,
good
very
we
good.
question.
talk about. Yeah. So it integrates normally, right? So with a private link, so whatever you apply on the network load balancer will be honored by the private link, right?
And
Absolutely.
then one other feature request that you got from hirings, a new feature request: add network latency for local zones in the infrastructure performance capability of Network Manager.
Yeah, definitely. If there is a PFR, we can route it. It's a different team, but we can route it to the network manager team. Yeah.
Yeah,
100%.
definitely. Yeah, sorry, I was having some issues with my camera there for a moment, but the squirrel was visible. But yeah, no, the private link, as you know, is an extension. Basically, when you're doing a private link endpoint attached to a network load balancer, it's kind of like an extension of that network load balancer's NIC, for lack of better terms, network interface, into another VPC, or it's a regional construct as well. So it's into another VPC. It could be even to another AZ. You could do that. That whole thing there is just the extension. It doesn't change any way that the network load balancer will operate. And it does and it adheres to all the rules of the listener that the private link is actually the service is subscribed to, that the network load balancer is hosting. So it's a very good question, but it doesn't have any effect. Configurable idle timeout on the listener, which the private endpoint connects you to, will be honored.
Yeah. And an example of that is like in order for you to communicate with a gate load balancer, you must have a gate load balancer endpoint, right? And the gate load balancer endpoint will also honor, right? Which is powered by private link, right? Yeah.
Powered by private link.
Yeah.
So very good. Any other further questions or anything else we should bring up? We only have a couple of minutes left, so if anything, we could wrap here.
No more questions.
Final thoughts. Milind, final thoughts. What do you want our audience to take away from our conversation, which will be on, by the way, on the routingloop.net / previous episodes, or previous or back, I think.
Yeah, no, I think just wanted to say thank you. This is the best part of my job, interacting with our customers, partners, our friends who ask really good questions. And I go back usually and say, okay, wow, that was a good question. I never thought about that. So it does happen a lot of times, as always. So this is, I don't know if you guys learned or not, but I enjoyed with this interaction. So hopefully I can keep coming up frequently.
Yeah. And any final thoughts? Yeah.
No, same here. I'm excited about this feature. I remember when we launched NLB back in, so yeah, I'm kind of old in AWS. Somehow, when I started, we only had the classic load balancer, just for an understanding here. Right? So we used to call that ELB back then, and then we launched the ELB, and then we started calling the classic load balancer. Yeah. But when I remember network load balancer, one of the things that customers always ask is like changing the idle timeout. So I'm super happy to see that happening today, and excited to see how customers are going to be using it. And again,
Felipe,
yeah, sure. Go ahead.
Sorry, go ahead. No, I was just going to make a joke.
And again, folks, if you have questions about anything specific about NLB or ELB, or whichever load balancer you're using, talk to your solutions architect, talk to your technical account manager. They know how to find us. You can mention our names there. We are happy to discuss stuff if you have something interesting for us. Okay.
Absolutely. And the way to do that, again, reach through your account team. They can reach Felipe, they can reach myself, and Milind as well. So
absolutely,
feel free to reach out. Thank you, guys.
We also posted this on LinkedIn, so feel free to continue the interaction there as well. And I was just going to make a joke on Felipe. He said he's older in AWS. I was going to say, from a different vantage point, it's so much better to be a long tenured in AWS than old in real life. I'll tell you from my own example. So
yeah. Well, yeah, I feel lucky that I joined when I was young.
There you go.
Thank you then, folks. I appreciate your time.
Thank you.
Have a good one.
Thank you very much.
Thanks a lot, Jamie. Always a great call. I enjoy coming to your show. Fantastic show.
We'll have you guys both on again.
Thanks, guys.
Cheers.
Bye.
Bye.